For this example, we're going to write a polynomial in standard form with the following roots: x equals 1 and x equals 3 plus 2i. I notice that one of the roots is an imaginary number, complex number, because of the I unit, and I know that every complex root comes in a pair. So the complex conjugate, if you have a plus bi, 3 plus 2i, then you would have a minus bi, or 3 minus 2i. Now I'm going to turn each of my roots into a factor. So first I'm going to write the polynomial in factor form and then convert that to standard form by multiplying. So how do I turn a root like x equals 1 into a factor? I would write x minus 1. How do I turn this into a factor? I would have x minus the 3 plus 2i, but because it has two terms, I have to put it in parentheses. So my final factor is x minus this, but again, it has two terms, so I have to put it in parentheses. Now I'm going to focus first on my last two factors, and I notice that there is a -1 that I can distribute to both terms in the parentheses. So still my first factor is x minus 1, and let's rewrite both of my second and my third factor. So my second factor, I have x, and if I distribute a -1 to both terms, -1 times 3 is -3. -1 times 2i is -2i. My third factor, I'm going to distribute that -1 again to both terms. So I have x, -1 times 3 is -3, and -1 times -2i is positive 2i. So again, I'm focusing just on the last two factors, and I'm going to be putting parentheses around the x minus 3's. So if I do that, and I look at multiplying just the last two factors together, you would start with this term, and you would distribute that to both terms in the second parenthesis, right? So when you distribute it to the first term, x minus 3 times x minus 3 is x minus 3 squared. And if you distribute it to the 2i, you would have 2i times x minus 3. Then you would distribute this to both terms. So I would have -2i times x minus 3. Now remember, we just distributed x minus 3 times positive 2i. And if you do -2i times x minus 3, that creates a zero pair. So you can actually shorten your work every single time if you put those parentheses around and say, all I need to multiply really is this first pair and this last pair here, because the middle pair gets canceled out. So if I have x minus 3 times x minus 3, that's x minus 3 squared, and -2i times positive 2i is -4i squared. So I'm going to continue to simplify this, and eventually I will still multiply it with the x minus 1. So x minus 3 squared is x minus 3 times x minus 3. And then I have -4, and instead of I squared, take a look. I squared is the same thing as -1. So let's plug in a -1 right here. So now let's distribute the x to both terms. So x times x is x squared. X times -3 is -3x. Now let's distribute the -3 to both terms. -3 times x is -3x, and -3 times -3 is positive 9. And then this part here, double negatives, that makes a positive 4. So taking a look, I can combine my x's here. -3 minus 3 more is -6, and I can combine 9 plus 4, which is 13. So if I rewrite this, I would have x squared minus 6x plus 13. So that's a trinomial that I still need to multiply the x minus 1 with. So in the end, I need to take x minus 1 and multiply it with x squared minus 6x plus 13. So let's distribute the x to all three terms. X times x squared is x to the third. X times -6x is -6x squared. X times 13 is 13x. Now I distribute the -1 to all three terms. -1 times x squared is -x squared. -1 times -6x is positive 6x. -1 times 13 is -13. Let's take a look at what we can combine. I have -6 minus 1, which would be -7x squared. And then I have 13 plus 6 more, which would be 18x's. So my final polynomial here in standard form should go highest degree to lowest would be x to the third. Remember you had -6 minus 1 more, so -7x squared. 13 plus 6 more is 18x, and then minus 13.